All right, guys, welcome to this page of the notes. Let's go ahead and talk about our second objective, which is maximums and minimums. And there's this really neat trick I'm going to show you guys here. I think you'll like a lot that'll make finding these maximums and minimums really, really easy. And here it is. If the coefficient of the x squared term is positive, meaning a, right? If a is a positive number, then the parabola is going to open upward, and the function is going to have a minimum value at the vertex. Why is that? Well, here's why. If this is my vertex, and a, my leading coefficient, is positive, I know that my parabola from that vertex is going to open up. Here's what that does. That makes my vertex the lowest value, right? It is the lowest point. There are no points below my vertex. That makes it a minimum, right? So it'll be the minimum value. The vertex will be a min. Okay, the other way, if the coefficient on the x squared term is negative, what this means is if a is a negative number, your leading coefficient is negative, well, your parabola in that case is going to open downward. It's going to open down, and your function will have a maximum value at the vertex, and here's why. If my vertex is up here, and my leading coefficient, my a, is negative, from that vertex, my parabola is going to open down. That makes my vertex the highest point, right? There are no points above my vertex. Since that's the highest point, it makes it the maximum point on my graph. So, if a is negative, your vertex will be a maximum. And if a is positive, your vertex will be a minimum, right? If the graph opens up, vertex is a min. If the graph opens down, your vertex is a maximum. Let's go ahead and get some practice doing this on the next page. What I've done is I have given you here a quadratic function, and we're going to go ahead and find a bunch of stuff. I want you to determine whether the function has a maximum or minimum. I want you to find the maximum or minimum value and state the domain and the range. Well, in order to find the vertex, right, I first need to find the axis of symmetry. So here we go. Let's find that first. I know that my axis of symmetry is x equals, there we go, now you can see, x equals negative b over 2a. All right, well, let's do that. My b is a positive 12, so that would be a negative 12. My a is a minus 1, which means I'd have a minus 2. Well, a minus 12 divided by a minus 2 would be a positive 6. Okay, now what we do in order to find the vertex, right, is we plug that into our function. So I would have negative 6 squared plus 12 times a negative 6 plus 8. Let's see here. A negative 6 squared is going to be 36, but then make it negative again, so minus 36. 12 times a negative 6 would be a positive 72. We'd add 8. Don't fat finger something on your calculator, and you should get a positive 44, which means then that my vertex, which is what I was looking for, is at minus 6, positive 44. Okay, great. Well, now here we go. My a value. A is equal to a negative 1. Remember, when my leading coefficient, my a, is negative, that means that my graph opens down, right? It'll be a parabola opening down. That makes my vertex the highest point, right? Because I would start at my vertex and go down from there. So I now know that this is a maximum. It's a maximum at negative 6, positive 44. And the last thing that they ask you to do is go ahead, actually let me write that for you. That means it opens down. Again, that was on the previous page of the notes. And the last thing they ask you to do is to find the domain and range. Well, we can do that. Now, for a quadratic function, remember the way that these work. You need to, for the domain, find all of the x values, right, that are defined by the function. Well, for a parabola, right, a quadratic, it'll be all real numbers. Right? There aren't any, right? Pick any value of x you want to. Positive, negative, rational, irrational. Pick any number. You can plug that into this function and get a y value. Any number you want. Try a couple, right? In fact, there aren't any, right? There isn't a single value that you could plug in here and not get a y value. Every single real number will work. And so my domain will be all real numbers. But the range, the y values, this one's a little different. Remember, this is the point where my parabola starts, right? -6, +44, and then it opens down from there, which means anything above 44 is not included. You can write this one of two ways. I don't care which way you do it. You can either do y is all values that are less than or equal to 44. And again, it would be less than or equal, right? Because my graph is opening down. So I'm starting at y equals 44, and then my graph goes down from there. So all values of y less than or equal to 44. The other way you could write this is in interval notation, right? And we would write this in interval notation the same way that you would read a book, right? You start at the top of the page and you work your way down the page. We read our graphs from top to bottom. Well, since my maximum value is a 44, I would start with 44. And I would use a bracket because 44 is included, right? 44 represents my vertex. So 44 is an included point, right? Same with this less than or equal, right? The equal means that 44, the bracket means 44 is included. And then it would be everything below 44 as far as you can possibly go in the negative direction, which we call negative infinity. But now I'm not going to use a bracket, I need to use a parenthesis. The reason I need to use a parenthesis is because negative infinity isn't actually included, right? Negative infinity is an idea, not a number, right? Infinity is not a number, it's an idea, right? No matter how big a number you write, there's always a number bigger than it, right? So there's no way to actually include infinity, because as soon as you pick a number that you think represents infinity, I can come up with a number that's even bigger. Right? So we're just going to put a parenthesis around it because it means not included. So 44 is included, negative infinity not included. That's reading from top to bottom. From my vertex all the way down as far in the negative direction as you can possibly go, which we call negative infinity. Either one of these I'll accept as a perfectly good answer to the range. Let's try another one. Maybe we can get through this one here. Now that we've done one a little bit faster. Here's my quadratic. Let's start off with this. I know that A is equal to a +3. That means that my parabola is going to open up. Right? If A is positive, the parabola opens up. Now here's what that means. Once I find my vertex, I know that my vertex is going, right? If I plot my vertex and my graph opens up, my vertex is going to be the lowest point. It's going to be a minimum. Let's go ahead and find that vertex. We do that by finding my axis of symmetry first. Let's see here, my B is a -12. Negative times a negative would be a +12. My A, so 2 times A, which would be 2 times 3, is going to be a 6. And we wind up with a +2. Let's go ahead and find the vertex then by doing f of 2, which means I'm going to have 3 times 2 squared minus 12 times 2 plus 7. I think we can do this in our heads. 2 squared is 4. 4 times 3 would be a +12. -12 times 2 would be a -24. We're going to add 7. don't fat finger something on your calculator, and you should come up with a -5. So that means that my vertex is at the point 2, -5, and we already discussed the fact that that is a minimum. Right? I know that once I plot my vertex, my graph will open up from there because of the value of A. Now, the domain and range. Well, again, pick some values of x. I'm telling you, there is no value of x that you can't plug in here. You can plug in any real number, they'll all work. So my domain is all real numbers. The range. In fact, for parabolas, for quadratic functions, the domain will always be all real numbers. The range. 2 ways you can write it. Let's practice both. -5, right? This vertex, 2, -5, represents the minimum value. I would plot my vertex. It opens up from there, which means that any values below -5 are not included. Only the ones that are greater than -5 are included because my graph opens up. So you could write it one of 2 ways. You could either write y is greater than or equal to a -5, or you could write it in interval notation. Again, we read from the top of the graph down. So because my graph is opening up, I would start at positive infinity, which is not included. That's why I need to use a parenthesis. I can't include infinity. And then it'll be everything coming down to -5, my vertex. But -5 represents my vertex and is included, so I would use a bracket. Again, the reason that the infinity comes first is because I read my range from top to bottom, right? And since my parabola is opening up and goes as far up as real numbers go, infinity, we start at infinity and come down to my vertex in this case because we read top to bottom. Guys, thanks for joining me so much on this set of notes. Hopefully now you feel really comfortable with graphing a quadratic by finding the axis of symmetry, finding the y-intercept, and the vertex. Also, you should be comfortable at this point with quickly determining whether the value of A makes your vertex a max or a minimum, and finding the domain and range value. Guys, I sure had a lot of fun on this set of notes. Thanks for joining me, and I'll see you next time.